Hello dear students, I am Yasser Salahuddin and I am with you for the first time to discuss chapter 4, which is the electrochemistry. We are going to discuss the chapter in a new way, in a smart way, and I will wait for your response and for your comments to give us your feedback on that way that we will study that chapter in a different and in a smart way. We will go to discuss the electrochemistry, which is a branch of science which studies the exchange between the chemical energy and the electric energy in or through a spontaneous or non-spontaneous redox reaction. Okay, chapter 4, which is talking about the electrochemistry. We are going to discuss chapter 4 in 4 sessions, okay? And now we are going to take session 1, which is talking about the galvanic cells. Okay, here is the content of the session: the electrochemistry and its idea, the redox reaction, which is the mean to transfer from the electric energy into chemical energy, and the galvanic cells, which is one of the electrochemistry application, and it's the first section we can study in chapter 4 and in electrochemistry branch. What is the electrochemistry? Electrochemistry is a branch of the chemistry or of the science which studies the exchange between chemical energy and electric energy, and that exchange is done through a redox reaction. And if you divide that word redox reaction into red and ox, you can get reduction reaction and oxidation reaction. Okay, the electrochemistry, from its name, you can exchange from the electric energy to chemical energy, and from chemical energy to electric energy. How does that happen? Galvanic cells or voltaic cells, you can change from the chemical energy into electric energy through redox reaction. And in the electrolytic cells, you can change from the electric energy into chemical energy, also through redox reaction. But this could happen through spontaneous redox reaction, and that could happen due to non-spontaneous redox reaction. Okay, what is the difference between spontaneous and non-spontaneous? Spontaneous means that it's done without interfering of the human or without control. It's done by itself. But in the non-spontaneous, you could make it by electric energy or by forcing the chemical reaction to be done. Okay, galvanic cells or voltaic cells, you can change from the chemical energy into electric energy through redox reaction, which is done spontaneous by itself. Could we discuss the redox reaction? Yes, of course. The redox reaction, you can divide it to 2 words: reduction and oxidation. Redox reaction is the reaction that includes the transfer of electron from one substance to another. Okay? You can transfer the electron from one substance to another through the oxidation and reduction. And you can summarize the idea of the redox reaction through 2 words: oil and rig. Oil means oxidation is losing electron. Rig means reduction is gaining electron. And if you lose electron, the negative charge will get down and the positive charge will get up. So you can change from the neutral atom to positive ion when it loses electrons. So when you lose electron, you are making oxidation reaction. And here, if you have copper positive 2 and it gains 2 electrons, you will change into copper neutral atom. So if you lose, you are making oxidation reaction, and if you gain, you are making a reduction reaction. So if you see that copper changing into copper positive, you are making oxidation. And if you see that copper positive 2 is converting into copper neutral, you are making reduction. And if that reaction done spontaneous without any interfere, without any control, if it's done by itself, it's gonna be called spontaneous redox reaction. Okay, the spontaneous redox reaction, we can discuss it by representing that experiment. You can put zinc plate in a blue solution of copper sulfate. This is blue solution of copper sulfate. So you have copper with positive 2 charge, and here you have zinc plate so it will be neutral charged atom. Okay? If you leave zinc plate in the copper sulfate spontaneous without any interfering, the zinc will dissolve in the solution, making zinc positive 2. Replacing the copper in its solution, so the copper will gain the electron and changing into copper neutral. And that what's called spontaneous redox reaction. So the spontaneous redox reaction is done without interfering of human and with itself by spontaneous mean. We can see that in that experiment, so the zinc is dissolving and the copper is precipitating. So it converts the zinc 0 or the zinc neutral atom into zinc positive 2, zinc charged cation. And the copper positive 2 is changed into copper 0 or copper neutral atom. So you are here making lose of the electron, so it's oxidation. You are here making gaining of the electron, so it's called reduction. So you cannot make oxidation without making reduction, and you cannot make reduction without making oxidation. And they are a part of the redox reaction. You have half reaction called oxidation and half reaction called reduction, and they are together called redox reaction. You can conclude that zinc from the neutral charge, it comes to be zinc positive 2, and the copper positive 2 comes to be copper neutral. So you have oxidation and you have reduction. You are losing and you are gaining. You are transfer the electrons from zinc to copper. So it's a redox reaction which transfer the electron from one substance to another. The conclusion that you have oxidation reaction, and if we divide the reaction to oxidation and reduction, so the oxidation is done in the anode and the reduction is done in the cathode. So the metal that is losing, you can name it anode, and the substance or the metal which is gaining, you can name it cathode. So you have the oxidation reaction in the anode, half cell reaction, and you have the reduction reaction in the cathode, half cell reaction. In all galvanic cells, anode is making oxidation, and in all galvanic cells, cathode is making reduction. Okay? So anode half cell is zinc when it loses the electron, so it transfers to zinc positive 2. And here, copper positive 2, which is gaining 2 electrons to change into copper neutral atom. And that we called a spontaneous redox reaction. All we have done that we are putting a zinc plate in a blue color of the copper sulfate. So the blue color disappears by replacing the zinc after the copper, and the red color deposited here by precipitating off the copper on the zinc plate by gaining the electrons the zinc leave on the rod. Okay, you can use that reaction, the spontaneous redox reaction, in the electrochemistry and in galvanic cells. What is galvanic cells? You know, the batteries is an application of the galvanic cells. In batteries, you change the chemical energy into electric energy, and this is done through spontaneous redox reaction. All you are making is putting two metals together in the battery, and by connecting it to a closed circuit, the higher oxidation potential atom, the atom which has the higher tendency to lose, are going to lose, and the atoms which have the higher tendency to gain are going to gain. So by spontaneous mean, without any interfering, the redox reaction will happen and it will produce the electric energy. So you can call it galvanic cell or you can call it voltaic cells, because it is producing the volts or the electric energy. Okay, the first galvanic cell in the history was Daniel cell. We are going to discuss the component of the galvanic cell and how does it work, its idea, And we are going to represent the galvanic cell by a symbolic representation, and we are going to talk about a very important component in the galvanic cell, which is the salt bridge. We can start with its composition and its drawing. It's very important. Okay, when you're having an anode, you are having a metal with high oxidation potential, which is the metal which has the higher tendency to lose. And when you have a cathode, you're having a low oxidation potential, and that is the metal that has higher tendency to gain and higher ability to gain. Okay? And if you connect both of them together, you will get a spontaneous redox reaction. The anode, which is zinc, are going to dissolve in the solution. So you are going to change the zinc into zinc positive ions. And copper positive 2 that is in a solution will deposit on the copper plate. You are going to see. Okay? Zinc is going to dissolve and it's going to lose electrons to change from zinc neutral atom to zinc positive 2. And it will lose electron that is transferred through the external wire to get here on the copper rod. And copper positive 2 are going to deposit on the copper plate. You will see that zinc in the zinc plate are going to dissolve, are going to lose. They are going to making an oxidation reaction. And now we are going to see how does that happen. Okay? Zinc in the zinc anode rod will dissolve in the solution to change into zinc positive ion. And it will lose electrons that is traveling through the external wire. As you see, the negative electron are going to be on the copper rod. So the copper positive 2 positive ions will deposit and attract it to the negative electron. It will attract them and they will go on to gain electrons. Okay, as we have seen, the anode is going to make an oxidation and the cathode is going to make a reduction reaction. So that will be the redox and the spontaneous redox reaction. Okay, what is this? What is voltmeter? The voltmeter is an apparatus that is used to measure the potential difference or the strength difference between the anode and the cathode. And by the way, it will measure the electric energy which is going to get out from this galvanic cell. Okay? Don't forget that any electrolytic cells can have a key to open and to be closed when the experiment is done or when the reaction is done. And what is this? This is the salt bridge, and we are going to discuss it separately on its own. Okay, so the Daniel cell or the galvanic cell is making anode and cathode oxidize and reduce. So you can transfer electrons from one substance to another, and you will have closed circuit to produce electric current or electric energy. Okay, we can discuss the component of the galvanic cells. What is the galvanic cells composed from? Okay, we have two half cells connected together by salt bridge. Half cell which is called anode, and you are going to make oxidation in that. And the half cell which is called cathode, and you are going to make reduction in that too. Okay, we are having anode and cathode, we are having oxidation and reduction, so you have redox, spontaneous reaction. Okay, you have two metals, and each metal dipped in a solution of its ions. Two metals, each metal dipped in a solution of its ions. How? If you have zinc, you are going to dip it in a solution of zinc sulfate. And if you have copper, you are going to dip it in copper sulfate. And make a concern that you are not making copper carbonate solution. Why? Because copper carbonate is a PPT. So as we have studied before in chapter 2, that copper carbonate is a PPT. So you have to choose a solution which is aqueous or which is soluble in water. Okay? So we have two half cells, each half cell containing metal, and each metal dipped in a solution of its ions. The two metals are connected together by external wire, and the two half cells are connected together by salt bridge. It's the composition of the galvanic cells. Okay? How does the galvanic cell work? First of all, the anode is losing electron, so it is the source of negative charge. So you can be asked, why is anode always be a negative pole or a negative rod in the galvanic cells? Because at anode, oxidation takes place and electrons are lost and electrons are released. So it is the source of negative charge. How does the galvanic cell work? The idea of the galvanic cells is that you have anode that is make oxidation reaction, and you have cathode that is make reduction reaction. So at anode, oxidation takes place and zinc is converting into zinc positive ion, and it will lose electrons. In the cathode rod or in the cathode electrode, reduction takes place and copper positive 2, which is in the solution, is going to deposit and it will gain negative electrons to deposit as copper neutral atom. So when you summarize the anode and the cathode and you add the reaction number 1 to reaction number 2, you will get the overall reaction. So cancel the electron with each other. You will get zinc, which is transferring into zinc positive 2, and copper positive 2, which is transferring into copper neutral atom. So here we are making oxidation. Here we are making losing of the electron. Here we are making reduction, and we are making gaining of the negative electrons. Okay? And that how does the galvanic cell work? Okay, how could we represent all of these by a symbolic representation or by a cell expression? You have anode half cell and you have cathode half cell. At anode, oxidation takes place, as we have said before, and at cathode, reduction takes place. So if you will represent the drawing by cell expression, you will get us anode and cathode. And you have to say that in anode, oxidation takes place, and in cathode, reduction takes place. So zinc will be transferred into zinc positive 2, and copper positive 2 will be transferred into copper. So the two half cells are connected together by the salt bridge. So you can represent the salt bridge by two parallel lines. They represent the salt bridge which with its two parallel lines between the two half cells. And you will represent by that arrow the direction of the electron flow from anode to cathode. And that is a fatal and common mistake. Many students forget to draw the arrow that is representing the transfer of electrons from anode to cathode, because anode is losing and cathode is gaining. So we have to summarize that the two parallel lines represent the salt bridge and the arrow represent the direction of electron flow from anode to cathode. Okay, we can talk about a very important component, which is the salt bridge. What is the salt bridge? It's a U-shaped tube that is connecting the two half cells together. So you are going to talk about the composition of salt bridge. A U-shaped glass tube that is filled with a strong electrolyte. Why? Why strong electrolyte? Why not a weak electrolyte? Because the strong electrolyte is always ionizes into positive and negative ion. And we need the salt that is in the salt bridge to be completely ionized into positive and negative. The positive ion will be here and the negative ion will be here. And you will know that importance in the next slide. Okay? So we have salt bridge, which is a U-shaped glass tube filled with a strong electrolyte. And you have to know that this strong electrolyte cannot react with the anode half cell reaction and with the cathode half cell reaction. And the U-shaped tube is closed from both ends by a porous membrane. What is porous membrane mean? You know that your skin is a porous membrane, Yes, it has pores to release the sweat. Okay, porous membrane, that is membrane with pores to let something to get in or go to get out. So it's a selective permeability membrane. So it will allow some of the ions to get and some of the ions to release by the meaning of a porous membrane in the two ends of the salt bridge. Okay? And what is the importance of the salt bridge and the importance of the strong electrolyte here? First of all, the salt bridge is connecting the two half cells together. So without the salt bridge, it will be no electric current, because any electric current to be produced will need a closed circuit. So the salt bridge is connecting the two half cells together to produce the electric current and to allow the electric current to flow continuously. So the salt bridge is very important. First of all, it connects the two half cells together and it allows the electric current to flow continuously through making a closed circuit. Okay? And what is the role of the strong electrolyte here? Let us imagine if you lose all electrons and you dissolve all the zinc positive 2. So that place will be full of the zinc positive 2 ions and there will be no room for any other zinc to dissolve. And here, if you are getting all the copper positive 2 here and leaving the sulfate negative ion. So copper positive 2 cannot be attracted because of the large number of negative ion that will be attracting the copper positive 2. So the strong electrolyte, which is ionized before to positive and negative ion, will absorb the excess positive and the excess negative in both two half cells. How? The potassium positive will absorb the sulfate negative ion. And how could you know that it will not dissolve all the copper sulfate salt? Because it will be a porous membrane, as we have said before. So it can absorb only the sulfate negative excess ions to leave the copper positive 2 to get on the copper rod. Okay, and here, all of zinc positive 2 will be dissolved and there will be no room for any other zinc to dissolve. So you will attract the positive excess with this negative ion to leave some space for some zinc to dissolve in the solution. Okay, so the salt bridge is very important in the galvanic cells. Again, the salt bridge rule, it connects the two half cells together and it allows the electric current to flow continuously through making a closed circuit, and it prevents the formation of excess positive and negative ion, so the electric current will not be stopped. Because if you will fill all of that with zinc positive 2, can you dissolve any other zinc? So there will no electron be transferred. And here, if you are attracting all the copper positive 2, there will be no copper to attract the electron. So you will not be able to making an oxidation or a reduction reaction. So the electric current will stop by formation of the excess positive and excess negative. So the salt bridge is very important. And here I can ask you a question. What happens when the salt bridge is removed? So, by easy as it is, the electric current will be stopped. And I can ask you another question, and it is, how does the electric current of the galvanic cells is stopped? First of all, if you remove the salt bridge. And second, if you remove the external wire, or if you open the key. Okay? And the other reason that will stop the electric current, if all of the zinc is dissolved and the anode is completely consumed, or the copper positive 2 concentration is lowering much. So there will be no copper positive 2 to be deposited or to attract another electrons. So you have three reasons that will stop the electric current in the galvanic cell. First of all, removal of salt bridge and removal of external wire and the consumption of the anode electrode. So all zinc is dissolved, no other zinc will be dissolved to lose electrons, or all copper ions are precipitated, so there is no copper positive 2 ions to get or to gain the electrons. Okay, after that discussion, I am going to make a summary for this session. First of all, we are going to say what is the electrochemistry. In other words, the electrochemistry is the science that studies the exchange between the electric energy and the chemical energy through spontaneous or non-spontaneous redox reaction. We have said that the electrochemistry is going to be branched into two parts. The first part is the galvanic cell. The galvanic cell is a system which changes from the chemical energy into electric energy through a spontaneous redox reaction. And the electrolytic cell or the electrolysis cell is the system that changes from the electric energy into chemical energy through non-spontaneous redox reaction.